So in this presentation, we're going to look at some descriptive statistics, and we're just going to mention a bit about skewness. Now, so a sample of 20 claims amounts on a household policies, on a group of household policies, given the following data summaries. So the sum of the values from the 20 claims was 3,256. And when we squared the values and found the sum of those squares, it was 866,600. Okay, now calculate the sample mean and sample standard deviations for these claim amounts, and also comment on the skewness of these claim amounts given a reason for your answer. Now, the bit about skewness I'll come to, because it's not immediately obvious from the actual mathematics of the values given there, but it actually requires a bit of lateral thinking. So first off, let's calculate the sample mean. The sample mean is fairly straightforward. We denote it x bar, and we calculate that as the sum of the values divided by n, the sample size. And remember, n here is 20. Okay, so it is 3,256 divided by 20. And that's a straightforward enough calculation. The answer is 162.8. Okay. There we go. So 162.8. So that's the sample mean. Let's go on to the sample standard deviation. Now, what I've done here is I've included a special computational formula that allows us to calculate the standard deviation there very easily based on the presentation we're given. So there's two sort of formulations of the standard deviation formula. They're actually equivalent, but they're just phrased slightly differently. Mathematically, they're equivalent. And so we're going to use this one. And so we have all the information there. We have n, we have the sum, the x bar, which is the sample mean, and so forth. So let's have a look at this. There we have standard deviation. So yeah, so it is the square root of n minus 1. So there's 20 claims. That gives us 19. So n minus 1, n is 20. Therefore, n minus 1 is 19. We also put in 20 here. So 8, 6, it's essentially just put all the information into the relevant place. And we have 162.8 squared. So is that everything? Okay, so yep, looks good. Now it's just when you were dealing with calculations like this, you just have to double check. This works out as the. So when I just work all this value, it's just a bit of calculator work. I am going to write it as the square root of 17711. Okay, so this is what that would work down, reduce down to once you have done the bit of calculator work. Now that's the variance. This value here, 17711 or 17,771. That is the variance. The standard deviation, therefore, is the square root of the variance. So it's the square root of 17,771. And the answer to that, I'll just write it up here. S, or SD, S is the common way of writing it, is 131. I'll put a decimal place here. Actually, I put everything to one decimal place because I've done that with the standard the mean as well. So just to be clear, the variance there is 17,000 711.7. That's the variance. So the standard deviation is the square root of that, and it is 1331.1. Okay. That's a straightforward enough formula. But now, let's go back to this. Comment on the skewness of the distribution of these claim amounts, given a reason for your answer. Now, you sort of think, how would you go about this given the information that you're given? Because you're not really told that much else. You've had the mean and the standard deviation. But just remember, just remember we are dealing with financial data. And we're dealing with claim amounts. So the values of x must be positive, or must be greater than 0. Okay? So we can't have a negative number. We can't have a negative x. Okay? That's first off a very important thing. Now, also, the mean we decided earlier on, x bar, was 162.8. And the standard deviation is 133.1. Now, relatively speaking, that standard deviation is relatively high in comparison to the mean. Okay, so this is sort of very much a judgment call, but like essentially that does indicate that the data is relatively quite spread out. So but like again, that's just a sort of judgment call. Now, let's just sort of look at here. This is positive skew and negative skew. And essentially, this is what we're being asked. Positive skew and negative skew. Now, essentially, a relatively high variance means that, quite a lot of the data is sort of spread out. So essentially, if you sort of like we're going to say the positive skew means that we have most of the values are the lower values with a few high values that would bring up the mean, and therefore so we sort of still call that positive skew. So a lot of small number of high values skew it, whereas the opposite case is negative net skew. It's just a few low values would skew the distribution to the left-hand side. So remember we're dealing with financial data, and we can't have a negative value. So essentially, let's just sort of try and sort of guess what we're looking at here. So essentially what we're saying is that the fact that we have high, first off, our mean is going to be around here somewhere. And the fact that we have relatively high standard deviation means that the distribution is actually going to look skewed, just like the way I've drawn it there. So if it was very small, if the standard distribution, or sorry, the standard deviation was relatively small, we might get something like this instead, something like that. Just something that peaks there and goes down like that. But that is not what we have here. But that would be a small standard deviation. What we have here is quite a large standard deviation. So therefore, just sort of like quite a few values there taper off. So what we're going to sort of say is that I'm sort of overstating the point, but essentially what we're going to say is that there is a positive skew there. Strong positive skew. Okay, so that ends this presentation.